Hello guys, today we are going to see how to analyze two-factorial experiment by SPSS statistics. First, you just open your SPSS statistics software, then you've got these two pages. The second page, we come to the first column, then we start writing our variables. We can start with our replication rep, then the first factor of our experiment, silicon, the second one, salts. We have two factors, silicon and salts, and the third one, we have this dependent variable, which is evapotranspiration of the crop. We have a field experiment, agricultural field experiment. So we can represent our data here. So we have 3 replications for our field experiment, 1, 2, 3. For silicon, we have 3 levels of silicon. The first level has to be in each replication. The second level also has to be in each replication. The third level, we have 3 replication each. 1, 2, 3. 1, 2, 3. Then salt, we have 4 levels of salt in our experiment. So 1, 1. Just we have to make sure that each salt level has to be in each silicon level, so that we can write the first level of salt here, then the second one, 3 silicon, 3 replication, we have 9 salt level. I mean, we have 4 level of salts, which has to be each level has to be in each silicon level. So 2, 9 times, because we have 3 replication and 3 silicon. So 3 by 3, 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have our replication here, silicon levels, 3 silicon levels. Salt level, we have 4 salt levels, each level in each silicon level. 1, 2, 3, 4 salt level. And we have the values of our dependent variable, which is evapotranspiration. Then we have something to manage also here in variable view. So here for silicon and salts, we need to write what represent what. For example, 1 in the data view represents for our salt level, SL salt level 0, which is 0.6 decisimetres per meter at, and 2 represents salt level 1, which is 1.6 decisimetres per meter at. Then after writing the numbers which represents different levels of silicon and salts, then we directly go to analyze parts, general linear model. Then we go to univariate, because we have just one dependent variable, which is evapotranspiration. Then when we go to here, we find it like this. Then we just take our dependent variable to dependent variable box, our factors which has two we have two factors, silicon and salt. We just put them in the fixed factor box. Then we go to plots. We can put our salt factor in a horizontal axis, then the silicon in separate line, then add, continue. Post hoc, we select both of our factors, then we highlight LACD and Duncan to test. Then we go to option menu, then descriptive statistics and homogeneity test has to be highlighted, then continue. Then we click on OK. We are now analyzing our experiment. Then we go to our output page. After analysis, we directly go to tests of between subject effects. Then we can see our two factors here. Silicon, for example, has no any significant effects on our dependent variable, which is evapotranspiration. In order for it to have a significant effect, its number here has to be less than 0.05 because our we are testing by making our level of significance 0.05. And when we come to the second factor, which is salt, it has a significant effect because its value here, as you can see, is less than by far less than 0.05. So it has a significant effect on our dependent variable, which is evapotranspiration of the crop. When we see the interaction effect of these both factors, these two factors, its interaction has no significant effect either. You can see here it's not less than 0.05. So when we go to the homogeneity tests, the table here, it is for silicon, it has no effect, as we said, and for salt it has an effect. You can put these values in your thesis or whatever, and you can start explaining or interpreting the result. You can assign this A, this one also A, and the second two B and C, and then you can interpret in a way that this value, the third and fourth levels of salt, no, the first and second of salt level has significantly high value than the rest of the salt levels. When it comes to evapotranspiration of the crop, we can interpret it like this. As you can see, this is the plots we found here in the output page. So it shows that as salt level increases, the evapotranspiration of the crop decreases, as you can see, in different silicon level. As you can see, this is the zero silicon level, this one is the second one, and this one is the third one. In each level, as salt increases, the evapotranspiration of the crop decreases. That's what it shows. And you can see also the values here as I interpret it: A, B, C, B. That's what I told you, and it's significant. Salt has a significant effect on evapotranspiration of the crop. So guys, thanks for watching my video. I will see you on another video next time. Thank you. Have a good day.